Hello, welcome back. In today's video, this very video here is going to be marking a change to this very channel here. So it's not just going to be about telling you about how Africa should be able to move. It's also going to be teaching you simple things you can do that can actually change the trajectory of your own life. And I mean everywhere. So from today, this channel is going to become BIA, means BIA. In other terms, build it Africa. That is what this channel is going to be. And to start with that, I was asleep yesterday. Before I awake, I was dreaming and I was doing something. I was turning one of my old junk stabilizer into a usable household appliance that's going to save me money. How did I run into this very problem here? I bought product from US that is actually steam cleaner that is actually 110 to 120 volts. However, in Africa, the standard voltage in Africa is 220. Now, to buy the step down that can be able to carry that successfully is a lot. It's going to take a whole lot of maybe like 100K. What is 100K? It's going to be taking like almost 200K to get a very good one from US. So when I had this intuition, when I had this like a dream in the night, I woke up in the morning and I changed my own life from there. And today, this very video here is going to be example of what those things I have been teaching you guys in the channel. So please, I'm having a very big problem, one of my big channel. And if you don't like my video, please don't subscribe to my channel. If you're gonna subscribe and you will not be watching my video, please don't subscribe, right? I don't want you to just come and fill my channel without watching my videos. Apologies, all right? So right now, this project is gonna be turning a common stabilizer which you have into all-in-one. It can perform stabilizing, which is stepping up a low voltage power to 220 volts, and it can also simultaneously be running the two tasks at the same time. It will be performing stepping down the power from 220 to 210, which is standard US volt. So from now, why is this very goal, this very DIY, build it yourself, build it Africa, very important? It's important because it's going to cost the cost for you. It's going to cut it, chop it down. Household stabilizers are much cheaper than step down. When you take a look at your local power stores, you understand what I'm saying. So without wasting your time, let's go, because this video is going to be lengthy and I'm going to take you every step-by-step procedure to get this built by yourself. With that said, let's get into the video. If you have an old stabilizer that you're no more using, or microwave transformer, well, this is going to be a big shot for you to transform them into something very usable. So without wasting your time, let's get started. At this very episode here, I'm not going to kill your time. So for this very episode, we're going to keep this one aside. We're going to be dealing with this one here. And every testing and the procedures which you're going to be needing here is what I'm going to be showing you here. And why did I consider this to be very ideal? That's going to be turning a stabilizer, a voltage step-up transformer, to work two ways for you, where you can be able to re-engineer it to be both a stabilizer and at the same time a step-down system for your utilities. I ran into a problem recently that involved me getting a step-down transformer, and I am on a tight budget. So I sooner realized that I'm having a stabilizer at home that I turn somewhere that I'm not using. So I decided I want to convert it into a step-down. But on the second note, I want to make a unique appliance, some sort of, it is a stabilizer that can step up a low power voltage up, and it's also a step-down transformer that can be able to step down voltage from 220 to 110. And offset, let's get in. Now, because the screws are stuck, I use a grinder to grind it off and remove this. Now, here is where things get interesting. It has a big transformer, and this very big transformer, from my studies during my secondary school days, it has a lot of center taps and outputs. And those outputs is what we're going to be working on. Now, because if we come over here right now, we have one outlet, two outlet that is connected from the same power. However, we can turn this very small output here to become our step down side. And how are we going to do that? I'm going to tell you just in a moment. Find a tripod and hang this on so that we start a practical demonstration. So guys, you can see 105 here. Let's see here again. We got it on 2 points. So we got it on 2 point here. 112, that's great. 140, that's too high. Low, low. So seems like this is the neutral point. Let's try to check this side. It's low, low. Okay, that's also great. $17 volts, 100 volt, 19, 110, 113. So we have found a suitable spot where we can tap from, and that fuels our project. So either from here and here, or here. Okay, let's measure from here to here. It's 30, from here to here. 40, 140, that's high. So I'm gonna check somewhere here, or somewhere here. 115. This is a good point here. 1010. Positive here and negative here. So we got 2 points here. That's okay. So from here, we can tap our power from here and here. Let me still check more. Okay, we still got another one here. Got another one here. So we still got another one here. So here we can got 2 outlets here. So from here, I can let's go here. I'm gonna shut this off, right? Power this off. Now I'm gonna desolder this too. Okay, my soldering iron is on. So I'll go ahead and lower this a little bit so that you guys can see it. Remember to remove it from power, alright? Remove it from power. I'll go ahead and solder this up. Now, also this little one. And before we do further, let's see how far. We want to plug it back in so we can be able to recognize which one is neutral here and which one is live. But the way I'm looking at it, so if we recognize the neutral, which definitely somehow is going to be the yellow cable here, then we can match it up. So this is the cable from the neutral side. So I want to identify which one is neutral here, so I'm going to go ahead and gonna power these up. Okay. If by the look of things, this will definitely be the neutral, but notwithstanding, we want to test it and be very sure. And in doing so, I want to disconnect this and reconnect this back. Be careful while working on live because it's back on. So I want to go ahead and let's trace the neutral part. You see, want to see it's near to 0, but if you put it here, that's also here. But on the other hand, we can simply find the yellow cable here. This is the yellow cable. This is the yellow cable. There shouldn't be two yellow cables inside the system. The yellow cable here. See the yellow cable right here. So we can turn this off, remove it from power circuit, and this is where using this meter becomes very strange, because right now I need to perform a continuity test. Select range, DC, AC. It's only DC, AC images. Range. So in that regard, I want to switch to another alternative. This is right now, so we go over here. We take the continuity test here. Okay. So I want to check here and here. So that's it. So that's the neutral. So the reason for that test is because since this is the neutral, we found this to be the neutral, we can leave this one behind. Then we can tap the second power from here. The goal is to have 110 here. So quickly, let me identify the power that goes from that place. It's actually a single wire. We can choose to tap directly from here, or we solder another one. We can solder the fresh one from here. So which is what I'm going to do right now. Ideally, this wire should be more thicker. Why? Because it's going to be a load-bearing wire, right? Wish I could find something more thicker. That would have been better. So here we go. Let's allow this to heat up so we can tap from here or here. Meanwhile, I've removed it from power, so you don't have to leave it when trying to get this, because this is a high voltage circuit. It can electrocute someone. So safety is the priority. Aside that, there is another power here, another wire here that is more thicker. And since this very fuse is no more longer working, I can equally cut it off. But I'm still leaving it to act like a fuse somehow. The wire, the power that's supposed to be feeding here to here is supposed to be thicker. That's what the message I'm trying to pass across to you guys. Like this wire right now, this is a pretty much thicker wire. So I'm going to solder it in one of the spots here. is the moment of the truth. Let's see if we can be able to get up to 110 volts from here. Okay, we're on. Now, if the work we've done, if the neutral is as we expected it to be, then we should be able to get up to 110 volts from here. That's perfect. Well, it's kind of going a whole lot of 130, but that's good. Now, this is where the magic comes. We should be able to get 220 volts from here. Yes, and you guys can see it right there. So it's a win-win situation. We're getting 110 from here, 140. I still need to tweak it a little bit, but you guys now got the memo, right? So I'm still gonna need to test. Let me test between this neutral here. Let me use this neutral here to find another sweet spot that's gonna give exactly 110, right? That's gonna be the best. Let's see here. Okay, we're getting one. No, this is. So what happened? That's high voltage, 280. Wow. Wow. 210. 170. 170 what? Let's get this. 150. So 15 volts. Now, in this regard, in order to solve this problem, because this is a problem, what we are expecting to get here is 110. But we're getting 140, 120, all right, 125. So in order to be able to perfectly get what we want from here, we're gonna be removing the light from here, and we're gonna be tapping it straight from where we got before. If we measure from here right now, if we measure from here, if we measure from here and here, you guys can see it's 103. From here, we're getting 140. So yeah, we can see it right there. So we can simply desolder this one from this circuit here. But if we desolder it from this circuit, it's not gonna give 220 from to here. So in order not to burn your system, you can simply write 220 on this side and write 110 on the other side. So 34 less here, 104. So we're gonna be getting a routing wire from here into the positive part, and that's gonna be the end of the show. We run this to here, and that's gonna be it. Problem solved. So I'm gonna turn this off, and we're gonna be back on the track. I'm gonna be back on the track. So in this regard, I'm gonna just come over here because I removed it from power. I'm gonna come over here and unscrew this so we can see this. Now, screw back in the other and make sure that it's not fit. Okay, so here now, we now have a capable personality that's gonna go ahead and give us what we want. So one of my biggest challenges actually with soldering. This thing is not really doing justice to what I'm doing. Sure. Okay, it's the moment of the truth. Let's start the testing. Okay. Put it back on. 210, and this is a 130, 140. I really don't get what's going on. Maybe there is an interference. Maybe one of the wire that is here, which I want to cut off, with the wire here, is creating an interference. Go back and test it. Wow, it's 130. Why? By the time I tested it here, let's test it here and see if it's giving 130 also. Okay, this is the one we're supposed to be switching to, not this one. So let's shut it off. And finally, our goal here is to get this one off and get it into here. There are two different power. This one is 130, 140. This one is 110, and this is the safe one we want. Uh, okay. Now, let's get back to testing it again, and this time, this is going to be the final. You can see it is on. So let's test here again. Finally, success. Now let's test this one here. That's good. So we now have 220 here and we have 111 here. So it's a win-win, guys. So guys, thank you for watching. Thank you for subscribing. I'll catch you guys later. To show you that this works, I want to test it with a real product. So you don't think I'm making anything up. Now we have the guy is still on. We have a Power Guzzler steam washer from US. I want you to read the sticker correctly. It's 110 volts, 120 volts, and this is the cord right here. The cord. So we want to go ahead and test it. So you can't use 220 volt on this thing here. You're going to damage it. So let's plug it on this output here that we just made and see what's going to happen. And here we go. It responded. So you guys saw it. It works. So thank you for watching. See you guys later.